Howdy y'all, so I'm Omar Yakum and I will be covering the tarantula, which is the example spider we had in the Protostomes lab. So I believe most people are probably familiar with this spider, especially because we saw one in the lab, but if not, here's an image. They're fairly large spiders, typically some of the largest ones, although they're not always the largest. They are a diverse group of spiders with nearly like 900 species, and they are hairy spiders. Those are the main three traits that you can observe right away. So the scientific name of the tarantula is the Aphonopelma, and they belong to the order RNA, which is the order that spiders belong. So first I'm going to cover their ecosystem relationships, see the habitats they live in, their prey, their predators, all that. So in terms of habitat, they like certain spaces like either natural cavities, under rocks, like on fallen trees, that kind of thing, where they kind of stay secluded, or in many cases they dig their own burrows to also serve this function of being like a space. And sometimes they can venture out from here, especially during mating, but a lot of times they just stay in this space and optimize it for feeding. So in terms of how they optimize it that way, they place webbing. It actually indicates the presence of prey, unlike most spiders, which use webbing to actually trap the prey. Tarantulas don't do that, but they do use weapons to detect them. In addition, they live in areas that allow for these kind of spaces: desert basins, mountain foothills, forested slopes. So these are areas that are dry, but also in many cases like rocky, or maybe with the forest you could see a lot of dead trees they could be under, or places they can dig burrows in. They also frequently stay on the ground, unlike other spiders that climb frequently because of the burrows they dig. Also, they have a very wide range with over 800 species. You can basically find them all over the world: Madagascar, California, Australia, the Caribbean, and they're not mentioned here, but South Asia, South Europe, all of that, all over the place. So this is a tarantula feeding, and I'll play the video again in a second. But first I'd like to cover it real quick. So basically the way it works is whatever burrow the tarantula has created, the prey will enter it. It'll be detected by the web. Almost think of it like kind of a tripwire that's left by the door, so that when it vibrates, the tarantula knows there's prey that's entered. So the tarantula uses its fangs, which are these right here that we show, and they inject venom into the prey, which basically liquefies it. So they do chew somewhat, but they only ingest the liquid prey. So in terms of what prey they have: smaller bugs, insects, crickets, grasshoppers, beetles, all that. In terms of predators, they have many natural predators like large lizards and birds. However, the most important I would say is the tarantula hawk, which, despite mentioning birds, aren't actually hawks at all. They are a type of moth. And the way these work is they incorporate tarantulas into their life cycle, so they actually paralyze them. They take them back to their own burrow. They bind them up and lay eggs on the tarantula, so that when the new tarantula hawks are born, they can eat the tarantula to get sustenance. So their role in the ecosystem, the main thing they do is control insect populations, because without natural predators, insect populations would balloon. There are already huge populations of insects. And in terms of what they do to humans, tarantulas are likely the common household pets. Obviously not as much as like dogs or cats, but in comparison to other spiders, they are some of the most common. And just having pets in general brings various societal benefits to humanity. So I'm going to also cover some traits involved with their evolution, the traits they evolved, what advantages it gives, and where they lie on the cladogram. So two unique traits that differentiate them from other spiders: they have their silk works differently, they have different glands, as you see here, and they also have fewer spinnerets. And this it goes back to the function of most spiders use their silk as a way of trapping prey. Tarantulas only usually use it as like a structural system, or as I mentioned earlier, when prey moves over, they kind of like a tripwire almost, trip the wire, and suddenly the tarantula can detect they're there and then go feed. The other system they have is these hairs, which are basically have like venom in them, and these can actually be launched at predators as a means of defense, kind of almost like a porcupine, but with a spider. And not all spiders have those types of hairs, which is very beneficial in terms of staying alive, surviving predators. Lastly, where they are on the cladogram, tarantulas are arthropods, like all other spiders. That means they have all of these traits that are mentioned here. A complete gut, whereas other things like flatworms or platyhelminths would have incomplete guts. Jointed appendages, those are legs, are probably the main thing for arthropods. They have body specialization and open circulatory system that utilizes hemolymph. And those are just some of the traits that you can derive from them being here on the cladogram, and obviously it derives more until eventually you get to the order. So thank you for watching this video. I hope you learned something from it, and these are my resources.